Hello, we're starting chapter 7, which is deals with survey sampling and inference. And you may also like to know that this is our second to last chapter we're starting, so we're getting closer to the end. So spring break, or not spring break, summer break is coming around, although with the stuff that's going on, it might not be much of a fun summer break. So here are our learning objectives for the chapter, and I would recommend that you pause the video and write all these down. Alright, so after you've written these down, at the end of the chapter, you should come back and when you to look at this list of things that you wrote down, and you should be able to answer every single one of them after all these videos for chapter 7. So the first section, 7.1, learning about the world through surveys. The idea of sampling, you're trying to examine a part of the whole. So the goal is to learn about the entire group of individuals called the population. The problem is it is usually impossible to collect data on the entire population unless you're the United States government, who performs a census every 10 years. And they collect data dang near almost everybody in the United States. The compromise is usually, well, not usually, it always is, collecting data on a smaller group of individuals called the sample, and we talked about that in chapter 1, selected from the population. So, the parameter and statistic. Based on a study, a report stated that 21.7% of all U.S. teens do not wear seatbelts. Well, the first question is, do they really know about all U.S. teens and their seatbelt habits? And how did they get that number? So they use a sample proportion to make inferences about the population proportion. So the parameter is the number used in the model of the population, and when we sample, we have no idea. In the real world, we never have an idea of what the true parameter is. But a statistic is a number that is calculated from the sample. So this 21.7%, that would be a statistic from the sample data. While this 21%, a statistic is an estimate on the parameter, so that would be how that relates, the statistic and the parameter. So survey terminology, the population is the group of people or objects we wish to study. A sample is a collection of people or objects taken from the population, smaller than the population, and a parameter is a numerical value that characterizes some aspect of the population. A statistic can be called an estimator and is a number derived from the data/sample. And a census is a survey in which every member of the population is measured. Example of that, our U.S. Census 2020 coming up. So, an example of a census, we know a census is a survey in which every member of the population is measured. But let's just say we wanted to figure out the percentage of people in our classroom who are left-handed. You can perform a census because the entire classroom is the population. So, dealing with inference, statistical inference. Statistical inference is the art and science of drawing conclusions about a population based on observing only a small subset of that population. And statistical inference always involves uncertainty, so an important component of the science is measuring our uncertainty. So that's the deal with, when you read the chapter, the standard error, that's what that is dealing with. And if someone ever asks you what stats is, it's quantifying uncertainty or risk. That's basically how I would describe it in a word or in a sentence. So, an example. A survey asked 1,000 U.S. college students if they preferred to study alone or with others. 420 preferred to study alone. So, we know that the population is all U.S. college students, and the sample is 1,000 students who were just surveyed. And the parameter of interest is P, the proportion of all U.S. College students who study alone. And the statistic is a proportion of the students who study alone. And that's 0.42. So 420 divided by 1,000, that's equal to P hat equaling 0.42. And then the statistical inference from this, we estimate that 42% of all college students prefer to study alone. And I should update that all U.S. college students. We don't know anything about different countries. So another example, genetically modified foods. I would like for you to figure out what the population is, the sample, the parameter of interest, the statistic, and what are inferences from it. So I would recommend you pause the video right here and see if you are able to find all these. Alright, so in January of 2015, the Pew Research Center published a report stating that 37% of all Americans believe that genetically modified foods, or GMOs, were safe to eat, and this was based on a survey of 2,002 American adults. What's the population and sample? What is the parameter of interest? And what is the statistic? So, the population is all American adults. The sample was the 2002 American adults that they pulled from that for that survey. The parameter of interest, what we're in interest of is the percentage of Americans who believe that GMOs are safe to eat. And what is the statistic? Right here. So our P hat would be 0.37, and the statistic is 37% of Americans believe that GMOs are safe to eat. And this is just the slide detailing what I just said before. So statistics versus parameters. I mentioned this before. Statistics are knowable. Anytime we collect data, we can find the value of a statistic, while the parameters are typically unknown because they can be estimated with these statistics, but these estimates will involve some degree of uncertainty. And here's a notation. So parameters use Greek letters on this side, and English letters are used to represent statistics. So we've already talked about half of these. Sample mean, that's X bar. Sample standard deviation, that's just the normal S. While the population mean is mu, and the population standard deviation is sigma. And then back to the statistics side, the sample variance is S squared, and the population variance is sigma squared. And the sample proportion is P hat, and the population proportion is just the regular P. And you may be saying, well, P is English. Well, this would also be known as rho in Greek. So, extra trivia for you. Bias. A method is biased if it has a tendency to produce an untrue value. Sampling bias results from taking a sample that is not representative of the population. So, for example, convenience sampling and voluntary response sampling. So an example of a convenience sampling is, let's say you're walking into the grocery store and there's these people that want to figure out what's your favorite food. So the grocery store is employing these people to ask these questions so that they can get more variety of this certain food. And you were selected and you were asked probably because it looked like you were smiling and in a good mood. That's usually what they do. And you answer pizza. That would be my pick. So that's an example of convenience sampling. While an example of voluntary response sampling is I forget what, but the company that tracks the TV ratings and stuff like that, they'll usually mail out these survey cards or whatever, and they'll usually stick a couple dollars in it or $1 in it for you to entice you to answer it, but you don't have to. It's just a voluntary response survey. So that's an example of that. And then measurement bias comes from asking questions that do not produce a true answer. So confusing wording, where it could be like, this question could be like a paragraph long. I mean, not everyone's going to read that, and they might just answer yes or no because they don't want to read it. Or like misleading questions, like, are you in favor of a fat tax? Okay, I mean, most people would probably say yes, but that would be misleading, because what if that tax was just a tax on sugar, like high sugar foods or whatever, like ice cream or whatever? Maybe not everyone would go for that, so that would be a misleading question. We ask people their income, and they are likely to inflate it, so that would be a bias. Our estimate will tend to be too high. Measurement biases occur when measurements tend to record values larger, or can sometimes be smaller than the true value. And then the third way this occurs because some statistics are naturally biased. For example, if you use a stat 10 times x bar to estimate the mean, you'll get estimates that are 10 times too big. Therefore, even when no measuring or sampling bias is present, you must always take care to use an estimator that is not biased. Sources of measurement bias. Measurement bias can occur in a variety of situations. Confusing wording and the use of non-neutral language in questions. Another sampling bias, convenience sampling. We sample only those who are convenient for us to sample, like the grocery store. You're walking by, you look happy, they want to talk to you. So convenience sampling is always biased, more likely to get people like you. Voluntary response. A large group of individuals is invited to respond, and those who choose to respond are counted. Voluntary response samples are often biased towards those with strong opinions or those who are strongly motivated and don't correspond to the population of interest. So, like, political polls, do you think Trump is the best president ever? So those who are strongly motivated, who really like him, are more than likely going to answer yes to that. While on the other end of the spectrum, they are going to be strongly motivated to answer no. So that would be, but like the people in the middle, you don't capture that part of the area, so it wouldn't be, it would be biased towards those with the strong opinions, but doesn't represent the entire population. And another example of this are internet polls. So that's where I got my idea of, because I'm always spammed with, do you think Donald Trump is the best president ever? And obviously I don't answer those, so that would be a voluntary response bias. And so internet polls suffer from what is sometimes called the response bias or non-response bias. People tend to respond to such surveys only if they have strong feelings about the results. Otherwise, why bother? This implies that the sample of respondents is not necessarily representative of the population. So, important questions to ask about sampling to avoid sampling bias. What percentage of people were asked to participate actually did so? Did the researcher leave out whole segments of the population who are likely to answer the question differently from the rest of the population? So back to that, is Donald Trump the best president ever? You're not going to get a response from me because I really don't care. So it isn't asking the entire population. Did the researchers choose people to participate in the survey, or did the people themselves choose to participate? So again, voluntary response bias, or were they randomly assigned? That's basically the important answers and questions If a large percentage of those chosen to participate refused to answer questions, or if people themselves chose whether to participate, the conclusions of that survey are definitely suspect and wrong, basically to say. So in an example, identify all the possible biases from this population. So I'm going to ask you to stop the video and answer all three of these examples really quickly. Alright, so this first one, that would be an example of convenience sampling. I mean, if you're going to ask all your Facebook friends, they're more than likely going to use Facebook to Twitter. So that would be a possible bias. So voluntary. A researcher asked 500 randomly selected people, are you in favor of the unfair tax burden that the hardworking, successful business people have so that the lazy unemployed can receive a paycheck without working? Okay, that's a very strongly worded question, so that would be an example of measurement bias. Yeah, definitely don't go that bias on the question if you want to do an independent survey study. And then on this last one, this would be a voluntary response bias. On July 4th, CNN posted on their website a question asking if they supported the current U.S. military operations. Almost 19,000 people responded. Well, not everyone that goes to the site has to answer that, so the ones that are more motivated to say, oh, I definitely don't like the current U.S. military operations are going to answer, and the ones that are very strongly pro for what our U.S. military operations are going to respond, while they miss the entire middle of the population. So another example, I would like for you to pause the video and maybe you can answer these. Alrighty, so 100 randomly selected Americans were asked by a researcher, do you currently have a sexually transmitted disease? Well, that's pretty upfront, and so that would be a form of response or non-response bias. Because, I mean, people might be embarrassed to answer that question if they do. And maybe there's a lot of people that don't actually really know because they're not being tested all the time. The second one, Gallup randomly selected 1,000 business phone numbers from the Yellow Pages and then called to ask if they supported government funding of high-speed rail. And the hint here is businesses have to pay to have their number in the Yellow Pages. Well, this would be an example of convenience sampling because you're missing out on a lot of small businesses who might likely be more in favor of these high-speed rails or less in favor. It just depends on where you are. So they'd be asking the higher, richer businesses rather than taking the entire, getting a more representative sample of the population. And then another one would be, this would be a convenience sampling as well, standing outside a grocery store and asking 250 shoppers, do you eat out at a restaurant at least 3 times per week? Well, if the people that are going to the grocery store, they might be more likely to say no because they're at the grocery store. And if he or she would do it at a restaurant, it'd be more likely that they would say yes. So that would be a convenience sample as well. Another example, finding sources of potential bias. A school district is interested in finding out what percentage of voters in the district would favor the passage of a school bond measure. The district sends out a survey to all school parents asking, do you favor the passing of a school bond measure to provide additional resources to improve educational opportunities for your student? So I can see, pause your video first. So I can see at least two. You'd be conveniently sampling your survey. So you're going to school parents asking I mean, they're more than likely are in favor to pass a school levy. And two, the wording of this question is very leaning, so it may sway people's answers too. Because what if the parent just seems like, I think whatever education is fine already, but then they read this and they're like, oh, well, wow, is there really more room for educational improvement for my son or daughter? That's a potential wording measurement bias. And I'd like to know your thoughts on all three of these example slides. Maybe there could probably be one or more ways to identify them. So here's the wording. So it's non-neutral language. Do you favor the passing? Blah, blah, blah. So, and it introduces a possible measurement bias into the survey and a convenient sample because it was all to all students or all parents of students at the school. And how do we collect a sample that has little bias as possible and is representative of the population? Only one way works is to take a random sample. And the most basic method that's easy to understand but is somewhat difficult is a simple random sample, or SRS. So simple random sampling, SRS, involves randomly drawing people from the population without replacement. So what that means is once someone is selected, like our hat example where we assign numbers to people and put them in a hat, we take them out, but we don't put them back in the hat, so they can no longer be chosen again. And then an SRS is one in which every member of the population and every possible sample is equally likely to be chosen for the sample. And if a scientific sampling technique is not done, we cannot learn anything about the population by looking at the sample data. The math doesn't mean anything if you don't collect the data in an unbiased type of way. So here's an example. Alberto, Justin, Michael, Audrey, Brandy, and Nicole are in a class. So the question is, select a SRS of 3 names from these 6 names. So first we can assign a number to each person. So Alberto is 1, Justin's 2, and so on. Now we can pull out our handy dandy random digit number table. So I'm just going to talk about this really quickly. So we're going to start at line 1, and we're going to select 3 names. So 2, okay, we get Justin. 1, we get Alberto. 0 isn't in this list, so we keep going on. And then 3, we get Michael. But let's just say we wanted to pick 4 people. Well, there's a 3 again. Well, we can't pick Michael again because simple random sampling is telling us not to select someone again because they're already selected. Oh, a 3 again, can't draw them. 2, we already picked Justin. 5, okay, then we get Brandy. So that would be our SRS of 4 people. And then this next slide, same thing. We're going to start from a different row. So we're going to start right here. 7, well, we don't have a 7th person or a person with the number 7, so we can't draw them. 7 again, same reason. 5, we can pull out Brandy. 9, no one's there. 8, no one's there. 2, we get Justin. 9, no one's there. 5, we already pulled out Brandy. And then 1, Alberto. So we'd get Justin, Alberto, and Brandy. Alright, that's it for the video for 7.1. Let me know if you have any questions. Attend office hours, class sessions, if anything's unclear. Thank you.